Hey there, math friends. Today we're going to talk about angles and triangles. We're starting topic 12, block 1. Meet Jada. This is Jada. Jada thinks that there are two kinds of shapes, two-dimensional and three-dimensional shapes. And she's probably right. The two-dimensional shapes have length and width, length, width, length, width, and so on. The three-dimensional shapes have length, width, and height, which helps give them their volume. Two-dimensional shapes have area. Three-dimensional shapes have volume if you measure all three of the sides and multiply them together. Anyway, two-dimensional, three-dimensional shapes. Now, here's Jada again. She's going to explain that many two-dimensional shapes are called polygons. The word polygon is derived from the Greek polis, meaning much or many, and gonia, meaning corner or angle. So a polygon is a closed figure with many corners or angles. And I should mention that they also have straight line segments for sides. So if you look at these shapes that are polygons, you'll notice that they are all closed figures, and all the sides are composed of straight line segments. Now, these others are not polygons because, well, not all of them are closed. Some of them are open. Some of them have curved lines. Some of them have lines that intersect over each other, and so they're a combination of things. But these are definitely not polygons. So you want to make sure that you don't get polygons and shapes that are not polygons confused. Now, polygons can be regular or irregular. Take a minute and examine the regular polygons and compare them to the irregular polygons. What do you notice about regular polygons compared to irregular polygons? What's the difference between the two? Jada thinks she knows. All right, well, that's enough of the suspense. Regular polygons, in irregular polygons, all the sides have the same length. So regular polygons have sides that are all the same length. In this triangle, all the sides are exactly the same length. This square has all the sides of the same length. This octagon, 8-sided figure, has all 8 sides are the same length, just like this pentagon and this hexagon. The irregular polygons do not have all the sides that are the same length, so that's the big difference. Regular polygons having all sides that are the same length. Now, one common polygon is called a triangle. Tri, of course, means 3, so a triangle has 3 angles. And because it's a polygon, it also has 3 sides. And these are some examples of the different kinds of triangles. You can classify triangles by their sides. For example, an equilateral triangle has all 3 sides that are the same length. An isosceles triangle has 2 sides that are the same length, and 1 side that is not. A scalene triangle. In a scalene triangle, no sides are the same length. They are all different lengths. Notice all sides, different lengths. Triangles can also be classified by their angles. If a triangle has one right angle in it, and that's a 90-degree angle, a perpendicular angle, then it is a right triangle. So here's our right angle for that one. There's a right angle in that one, and a right angle in that one. An acute triangle. In an acute triangle, all the angles are less than 90 degrees. Acute means less than 90 degrees. Aw, isn't that a cute angle? Because, it's smaller than 90 degrees. In an obtuse triangle, you have one angle that is more than 90 degrees. But you can only have one that's more than 90 degrees because the other two need to be less than. But you only need one angle that is more than 90 degrees for it to be obtuse. Now, you can also have, when you name triangles, they have a first name and a last name. You can have a right isosceles triangle, a right scalene triangle. You can have an equilateral triangle is by definition acute because all the angles are the same, and they're all less than 90. You can't have an obtuse equilateral because it's impossible to have one angle more than 90 degrees and the other two less than, but call it equilateral. But you can have an obtuse isosceles, and you can have an obtuse scalene. So there are lots of different types, and triangles technically usually have a first and a last name. The equilateral triangle, that's kind of like Beyonce. They only have one name. You don't have to worry about it. Or, Cher or Madonna, Prince. They only have one name, equilateral, and it covers everything. But you can have right isosceles, right scalene, acute isosceles, acute scalene, obtuse isosceles, and obtuse scalene. Anyway, there you have it. Let's see what Jada's looking at now. Oh, we're going to need to know about angles. There's all sorts of stuff you need to know about angles. And let me help you out here. An angle is the amount of rotation between two rays or line segments that share a common point. That common point is called a vertex. So here's the vertex right here. That's your vertex. And the angle is right here, as you can see. And that's between the two line segments or rays. Now, the difference between a line segment and a ray is that a ray has a starting point and goes on forever in one direction, but a line segment has an ending point and a starting point. But an angle is the amount of space in between those two segments, and it has that cool vertex. So you're going to definitely need to know these vocabulary words: line segment, angle, vertex, ray. All of those are important vocabulary words. Very, very important. And here we are now. Notation of angles can be tricky, and that's the truth. We use the symbol, this symbol right here. That's the angle symbol to indicate an angle. Sometimes, to name an angle, we only use the vertex, like angle A. So you can say that this right here, that's angle A, because A is the vertex. But sometimes, if you have more than one angle in a picture, you need to use 3 points to name an angle. This one, besides being called angle A, it could be called angle DAE, because it includes all 3 of those points with the vertex in the center. The vertex is always in the center when you name an angle. DAE. This could also be called angle EAD, depending on where you start. Now, what we have here are 2 angles that are together. But I want to show you something. Line EF, right here, this is line EF, can be thought of as a straight angle. And a straight angle, it's called a straight angle because it has a complete measure of 180 degrees. And a straight line is 180 degrees. Now, in this case, the measurement of the straight angle, FAE, is the sum of the measures of angle DAE and angle DAF. When you add those two together, they add up to 180 degrees, and they are called supplementary angles. Supplementary angles because the sum is 180 degrees. 112 plus 68 is 180. So these are called supplementary angles. Supplementary. This one and this one. Supplementary. Okay? Now, here we have a couple here. What do you notice about the measure of the straight angle and the sum of the two adjacent supplementary angles? Well, remember, a straight angle is 180 degrees. But look at these two. When you add 53 degrees plus 127 degrees, what do you get? Well, you get 180 degrees. So that means that the measure of angle DAF plus the measure of angle EAD is equal to 180 degrees. And that means that they are supplementary. Sorry about the handwriting. Okay. And over here, you should notice also that angle FAD in this one is 142, and the other angle is 38. And when you add those two together, yep, you get 180 degrees. So that means that these angles are also supplementary because they add up to 180 degrees. Okay? They are both 180 degrees, the same as a straight angle. You know, and a straight angle is just a line, but you have to name it with the 3 points. Now, in this topic, you will explore the different attributes of angles and triangles, and you'll look at what they have in common and how they are different. Before we do that, let's review the classification of angles, and we're going to label each angle with the appropriate angle name. Okay, there it is. Whew. Now, this angle here, the distance, the space between these two rays is 40 degrees. 40 degrees is less than 90 degrees, and so that means that it is acute. That's an acute angle. Now this next angle, this one measures 165 degrees between the two rays, and 165 is greater than 90 degrees. And because it's greater than 90 degrees, that makes it an obtuse angle. This one down here is 105 degrees between the two rays, and 105 degrees is greater than 90 degrees, and so that is another obtuse angle. And this one is exactly 90 degrees between the two. You see this little square in the corner? That tells you that's a dead giveaway that that is a right angle, because right angles are 90 degrees. Okay? Now, there are other important angles that you need to know about, and these angles come in pairs. I want you to notice something here. Okay, whoa, there we are. Sorry about that. Two angles that share a vertex. The vertex here would be vertex A. They share a vertex and a ray, but don't share any of their interiors, are called adjacent angles. Adjacent angles. And it says here that angle BAC and angle CAD are adjacent angles because they share this ray right here. They're next door neighbors. Okay? They share a ray and the vertex. Adjacent angles. Please make sure that you're drawing these diagrams and writing down this important information. Now, When lines intersect, there are two pairs of non-adjacent angles that are formed, and these are called vertical angles. Vertical angles. So, this one here, FGH and EGI, are vertical angles. And FGE and HGI, those angles are also vertical angles. And the important thing about vertical angles is that they have the same measurement as each other. So, whatever the measure of this angle is, this one will have the exact same measure. And whatever measure this one has, this one would also have the same measure. So if that's x degrees, then that one's x degrees. If this one is w degrees, then that one is w degrees, because they have the exact same measurement. They are angles that are right across from each other. When two lines intersect, they are vertical angles. It's really important to understand that they share the same measure. Now let's talk about a little bit more about supplementary angles. Remember, two angles are called supplementary if the sum of their measures is 180 degrees. Okay, when you add them up, they have to equal 180 degrees. Now you can see here that line there, remember, that would be called a straight angle, because you could have that point, and that point on it, and that is 180 degrees. When you add 85 degrees plus 95 degrees, you get 180 degrees. Not 180%. 180 degrees. Okay? But supplementary angles do not have to be adjacent. Notice that these are adjacent because they share this ray right here, but they don't have to be. Supplementary angles don't have to be adjacent. You can add any two angles together, and if they equal 180 degrees, they are supplementary. Notice here, this angle is 50 degrees, and this angle is 130 degrees. When you add 50 degrees plus 130 degrees, you get 180 degrees. Those two angles are supplementary. Okay? Now, if we study a few more angles here, we can see that these angles should be supplementary. This one is 45 degrees. When you add it to 135 degrees, you would get 180 degrees. If I were to take this angle here, the 45 degree angle, and put it right there, that would form right there, and we'd have a straight angle or a line, 180 degrees. Same with 60 degrees plus 120 degrees, that equals 180. 90 degrees plus 90 degrees, that's 180 degrees. 160 degrees plus 20 degrees, 180 degrees. These are all examples of supplementary angles. Easy stuff. Now there's another type of angles that you can set up in pairs, and they are called complementary angles. Now those aren't angles that are really nice to say, hey, I like your shoes. That's not the kind of compliment we're talking about. Any two angles are called complementary angles if the sum of their measure is 90 degrees. If you can add their measures together and equals 90 degrees, then they are complementary. Notice 50 degrees plus 40 degrees, that's 90 degrees. 60 degrees plus 30 degrees, that's 90 degrees. So these are complementary angles. And you can say that the complement of a 50-degree angle is a 40-degree angle, or vice versa. The complement of a 40-degree angle is a 50-degree angle. Complementary angles equal 90 degrees. So you can see here's some more pairings of those. 45 degrees plus 45 degrees is 90 degrees. 60 degrees plus 30 degrees, 90 degrees. 20 degrees plus 70 degrees, 90 degrees. 15 degrees plus 75 degrees equals 90 degrees. These are all examples of complementary angles. All of them. Complementary angles. When you add two of them together and they equal 90 degrees. Okay. Now let's take a look at this. What have we got here? We've got this really great pair of lines that are intersecting, and we can see that the measure between angle BED is 51 degrees. What is the measure of the other angles? Well, one thing you should notice right away is that angle BED and angle CEA, angle CEA, its measure would also be 51 degrees. How do I know that? Because they are vertical angles. And vertical angles have the same measure. How great is that? The other thing I should notice is that we have a straight line here, right? And if the measure of angle BED is 51 degrees, then the measure of angle DAE should be 180 degrees minus 51 degrees. And how much is that? Let's see. I think that should be 129 degrees. Because 180 minus 51 is 129, so this one would be 129 degrees. And the reason is because the measure of angle DEA and BED, those two are supplementary. Now, if the measure of angle DEA is 129, then this one should be 129 degrees also, because it is a vertical angle with angle DEA. So the measure of angle CEB is also 129 degrees because these two are vertical angles. See all the important information you can get from diagrams such as this, vertical angles, supplementary angles, lots of cool stuff. Now, let's take a look at this here. We're going to do a little bit of algebra. Oh no, algebra. Oh yes. Now, I want you to notice right here that first of all, the measure of angle BED or angle DEB is x. Okay? So the measure of angle DEB is x. So that means that the measure of angle CEA would also be x. CEA would be x. Why? Because it's the same measure as angle BED or DEB, whichever you want to say it. Now, we look at here, it says the measure of angle AED plus something equals 180. The measure of angle AED plus what equals 180? AED equals 180 if we add it to this other one. So what we could say is that measure of angle AED plus X is equal to 180. And that means that the measure of angle AEC, well, we already know that that is X. But what is the measure of angle CEB? The measure of angle CEB, this one right here. What's the measure of that angle? Well, if the measure of this angle is X, and these two form a straight line, 180 degrees, that means that they're supplementary angles to each other, and that means that their measurement adds up to 180 degrees. But we don't know what this one is. But if we subtract 180 minus X, whatever this is here, that will give us the measure of angle CEB. So, if we gave X a measurement, and we subtracted that from 180, that would give us the measurement of this angle here. So, just to review, these two angles are the same measure because they are vertical angles. These two angles are the same measure because they are vertical angles from each other. But these two angles here, okay, this one and this one, they are supplementary, and that's because they both add up to 180 degrees. It's kind of algebraic, but you'll be okay. We'll talk more about this later. Let's go to the next diagram. Holy cow, look at this bad boy. Now this one says that the measure of this angle right here, this is 5x degrees. Well, what the heck? What are they wanting us to do here? Well, if that's 5x, if the measure of this angle right here is 5x, what's the measure of this angle over here? Well, so angle BED, the measure of that is 5x, correct? Because it says so. The measure of angle CEA, that should also be 5x. Why? Because they are vertical angles. $5x. Now, what does that mean for the other two? Well, notice the straight line here. That straight line, that's a straight angle, that's 180 degrees. Well, if this one, if the measure of angle BED is 5x, then the measure of angle CEB, should be 180 minus 5x. Because whatever BED is, we give it a real number, if it was like 25, we could find the other one by subtracting 25 from 180, and that would tell us what it is. But since we don't know the actual number, we have to use it in terms of x. So this angle is 180 minus 5x degrees. And this one is 5x. Whoa, where'd it go? Sorry about that. This one is 5x degrees. And this angle here, well, it's vertical angles with with angle CEB. Good old angle DEB. EA, it's going to be also 180 minus 5x. And why is that? Because it's vertical angles with angle CEB. They're across from each other in the intersecting lines. Okay? All right, let's move on. I can't believe it. We're done. We finished the whole lesson. All right. Well, now you will find an assignment in Forms, which will be Topic 12, Block 1, where you get to answer some more questions relating to angles and triangles. Have a great day. Don't forget to be awesome. We'll see you next time.